For the past few years, the whole story of AI has been about one thing, just getting bigger and bigger. But what if the path to truly intelligent machines isn't about scaling up what we already have? What if it's about building something, well, fundamentally different? Today, we're going to dive into a totally new vision for AI, one that wants to go way beyond just matching patterns and get to something like real, genuine common sense. All right, so let's just jump right in with a huge question. We've all seen the headlines, right? These massive AI models trained on trillions of words. And the big assumption has always been, hey, if we just keep making them bigger, throw more data, more compute at them, we'll eventually hit AGI. But is that really the case? Is just scaling up the only way forward? Or are we maybe hitting a wall? So, to really get where we might be going, we've got to take a good look at where we are right now. And today's AI world, it's pretty much dominated by one piece of tech that has, let's be honest, captured everyone's imagination: the large language model. You know it as the LLM. Okay, so what is an LLM really? When you strip it all down, even the most advanced ones are basically just incredible next word predictors. They've swallowed a huge chunk of the internet to learn the statistical patterns of how we talk and write. And yeah, that lets them do some amazing things. But here's the key thing to remember: they don't understand the world like you and I do. They're masters of the pattern, not the reality behind it. And that leads us right into the fundamental flaws with this whole approach. Because for all their power, these models have some really deep limitations, and just throwing more data at them isn't going to fix it. Let's break down exactly why. So check this out. This really highlights the first huge problem. They're just incredibly inefficient learners. Jan LeCun, who's the chief AI scientist at Meta, points this out all the time. A teenager can learn to drive, a super complex, pretty dangerous task in, 20 hours? But the best AIs, they need millions of trials in a simulator to do the same thing. They basically have to experience every possible way to fail just to learn how to succeed. We don't do that. We use our common sense, our basic understanding of physics to know what's going to happen without having to, crash the car 1,000 times first. Okay, problem number 2, hallucinations. That's the fancy word for when an AI just makes stuff up. And what this research points out is absolutely critical. This isn't some bug that can just be patched out. Think about it. Since these models are only predicting what word sounds plausible next, without any connection to what's true in the real world, well, making up plausible-sounding nonsense isn't an error. It's an inevitable part of how they're designed. It's a feature, not a bug. And that brings us to the third big problem, and this one might be the real showstopper: diminishing returns. We're throwing exponentially more data, exponentially more computing power at these models, but the improvements we're getting back are slowing down. It's like we're flooring the gas pedal, but the car is barely speeding up anymore. This really suggests that we're hitting some kind of plateau, and that just making things bigger and bigger, well, it isn't the whole answer. So if scaling up isn't the whole story, then what is? Well, there's this other vision, championed by researchers like Jan LeCun, that offers a totally different path. The big idea is this: let's stop trying to build a better text predictor, and instead, let's try to build a machine that learns about the world the same way we do, the same way animals do. And yeah, the inspiration for this is totally biological. It's us. Instead of just feeding an AI a library of static text, this new vision is all about learning through watching and interacting with the world. It's about building an internal model of how things actually work, right from the ground up. Just think about how a baby learns for a second. In that first year, mostly just by watching, they build this incredible foundational understanding of reality. They figure out that when you hide a toy, it doesn't just vanish. That's object permanence. They learn things are solid. They learn that if you let go of something, it's going to fall. This step-by-step learning process, that's the bedrock of our common sense. It's a world model being built piece by tiny piece. And that brings us to the absolute core concept of this whole idea: the world model. This is the heart of it all. We're not talking about predicting the next word anymore. We're talking about building an internal simulator. It's basically giving the AI an imagination, an engine that lets it ask what if and play out the consequences of its actions before it ever does anything. Okay, so what does an AI built around one of these world models actually look like under the hood? Let's take a look at the blueprint for this new kind of intelligent agent. All right, I know what you're thinking. This diagram from LeCun's paper looks pretty complex. But trust me, the core idea behind it is actually really intuitive. It's basically a feedback loop that's designed to let an agent reason, plan, and act out in the real world. Let's just break it down into simple steps. Step 1, perception. The AI just looks at the world, sees what's happening right now. Step 2, the world model kicks in. It starts to imagine a few different things it could do, and it simulates what would happen for each of those plans. Step 3, the cost module. This part looks at those imagined futures and basically asks, which of these is good for me and which is bad? And finally, step 4, the actor. It picks the best plan, the one that causes the least discomfort, and takes the first step. Then the whole cycle just starts over again. Now, I really want to zoom in on that cost module because this part is the real driver of the whole system. It's not just about cold hard logic, it's a motivation system. You've got this hardwired intrinsic cost. You can think of it like the AI's version of pain or pleasure. And then there's a trainable part called the critic that learns to predict what actions will lead to those good or bad feelings down the road. What's so cool about this is that you could design an agent to be intrinsically curious, or even an agent whose core motivation is to help people. Okay, so what's the big picture here? What does all this add up to? If we actually build AI this way, what do we really get out of it? Well, the benefits pretty much line up perfectly to fix the flaws we talked about earlier. With a world model, the AI suddenly becomes way more data efficient. It can learn like us. It gets the power to actually reason and plan by simulating the future. It gets safer, right? Because it can predict and avoid danger without having to crash and burn first. And maybe most important of all, it starts to build a grounded, intuitive understanding of how the world works. You know, the very foundation of common sense. So here it is, the two big ideas side by side. On the one hand, you have scaling LLMs, which is all about memorizing statistical patterns from text. On the other, you have building world models, which is about learning how the world actually works through interaction. I mean, is the difference between an AI that can write a perfect-sounding paragraph about physics and an AI that actually understands why an apple falls from a tree? And that really brings us to our final thought for today. Look, the path we're on, scaling up these massive language models, it's been absolutely incredible, no doubt. But this other vision, it offers a path toward a totally different kind of intelligence, one that's grounded, efficient, and maybe, just maybe, a lot closer to our own. So it leaves us with this big question. If an AI could learn and reason and imagine, not just from text, but from the world itself, what would truly be possible?